Welcome everyone to the Internet of Interactive Things. So this is a more hardware. Am I on? Yeah. We have amazing speakers that will blow your mind. So get ready. And we're going to start with the first speaker from a company called NXP. He's going to talk about interacting with the connected home. Please join me in welcoming Ian Morris.
Thank you. Okay, great, thank you. Let me first, okay, just wanted to check that out. Hi, so good afternoon. My name's Ian Morris. I'm an applications engineer with NXP Semiconductors. And this afternoon, I'm going to be talking about interacting with a connected home, one of my focus areas as an engineer working on the Internet of Things. So firstly, a little bit of background about NXP, for those of you not familiar with us. So we're a semiconductor company, actually formed out of Philips Electronics back in 2006, I think it was. A group of private equity companies bought the semiconductor part of Philips Electronics, created a standalone company. Then in 2008, we were listed on NASDAQ, so now we're a completely standalone, separate entity from Philips, specializing in the manufacture, design, and manufacture of semiconductors. Pretty big company, about 20,000 employees worldwide, $5 billion of revenue. I think that makes us about the 5th largest semiconductor company in the world. Very broad-based, so we do everything from automotive, the connected car, cybersecurity. We're pretty famous for NFC. That goes on a lot of the cell phones nowadays. Obviously, medical electronics, portable wearable, and our focus, my focus and our focus kind of today is devices for the Internet of Things. So it might be obvious why a semiconductor company is interested in the Internet of Things to supply and sell silicon chips. Obviously, there's communication and networking chips that we sell into this application space. People may have heard of Zigbee. Undoubtedly, you've all heard of Wi-Fi, Bluetooth, etc. But it's not just about communication ICs. Okay, this is also about sensors. So the devices that connect to the internet need to know about the environment around them. So semiconductor companies have developed a huge array of different sensors. Temperature, humidity, light, those are just the basic ones. And you know, these things are evolving all the time. Also, processors. Okay, these devices need to be able to run algorithms to process the data from the sensors and other inputs they get from their environment. RFID and NFC, you may not be familiar with those terms, and we'll touch on that a little bit later. It's a kind of new technology for interacting with all these things that we connect to the internet. And then obviously, overriding everything are security ICs. Okay, so we can connect all these things to the internet. That create the connected home, but we really, really want it to be secure. And that's kind of I feel, and I think we feel as NXP, that's a secondary thought to most people that's now maybe coming more into the forefront of people's minds. Okay, so the Internet of Things, you know, we talk about the Internet of Things a lot. There's a lot of articles online about this. As this slide shows that really, you know, it says it's in the infancy. That's not strictly true. You know, we're going back to 2000 here, showing really when it started off. It started off way before that. People have been connecting things other than PCs to the internet for a long time, probably ever since the internet was invented. But there's definitely been a kind of progression from kind of very simple applications, barcodes on items of food, for example, that the reader is connected to the internet and can pass price information to the checkout, things like that. To more kind of semi-autonomous applications, security systems, transport systems, etc., that interact with themselves to a certain extent, but also a lot of human interaction there. And we're really seeing, we as a semiconductor company, are seeing the move to more fully autonomous systems, where these sensors work with them by themselves, with a local controller, to accomplish a lot of tasks without a lot of human interaction. Okay, so really, the Internet of Things is definitely evolving. Internet of Things, very wide area. Okay, so we've got industrial automation, we've got a connected car, various other areas. And my focus at NXP and the focus of our discussion today is the connected home. So there's actually a lot of devices when you think about it in the home that could be connected, and a lot of devices actually you may not be aware of that are already connected. Okay, and it all centers around us. Yeah, our desire to control these devices, to improve the environment around us by having control. Obviously, key to this is security. You don't want people snooping on your private data, being able to hack into your home network and your connected devices for nefarious purposes. So NXP did a study. We used some external data, okay, and did some work ourselves to try and quantify the connected home and what sort of devices and how many could actually be connected. The results are here, and it's quite amazing, really, I think. Average household, 200 devices could be connected, potentially, okay? And the interesting thing, really, is that lighting leads the way, okay? You think about how many light bulbs you have in your house. If all of these were connected, you may not get up to the 70 to 90 figure, just with light bulbs, but then you've got to think about light switches, okay? So for every light bulb, there's probably a light switch. You double the numbers, okay? And then light sensors you might want to add into your lighting system. So a huge amount of devices that can be connected to the internet just in your home, okay? And we're seeing this already playing out. Very, very famously, the Google Nest thermostat, okay? A lot of products already on the market. There's individual products from people like Philips, Belkin, et cetera, okay? Developing one-off point products, right through to home improvement stores, and now starting to sell connected systems, not just one device, but a system of devices. Mainly focused at the moment around security. It seems to be the key selling point, the key care about for consumers in order to get connected. And then, most interestingly, I think the MSOs, okay, like Xfinity, like AT&T, are now selling connected home systems. Okay, so I can go out to all these different vendors, and I can pick up right now devices that can help connect me to my home. They're all, or mostly, based on wireless technology, okay? Whether it's an IP camera that's going to use Wi-Fi because it needs the high-end, large amount of bandwidth, right down to the sensors, the locks, the light bulbs, et cetera, using different technology. You may be aware of Zigbee or IEEE 802.15.4, as it's called, and Z-Wave, okay? And semiconductor companies support all these different wireless communication standards. But it's good to understand this when we're talking about the connected home and how we interact with it, that all these devices, or the majority of them, are connected wirelessly. So a quick discussion about the connected home system architecture before we talk about how we interact with it, because it's important to understand some of the limitations that are placed on the connected home by the internet or the architecture of the internet at present. So when we're at home, traditionally, we have an app, we have a connected device, a door lock, a light bulb, et cetera. We send a message. That message goes to our access point in our home, usually, via Wi-Fi, and then it will be distributed out to the relevant device. Makes sense, right? It all stays within our local area network, usually. Now, when we're away from home, it gets more complicated. Due to the way the internet is architected, IPv4, the lack of addresses, we use a technology called network address translation. And basically what that means is that our cell phone, when we're away from home, can't talk directly to any of the devices that are within the home. So a lot of vendors, and nearly every product that we saw previously in the previous slide uses this technology, is to use a cloud platform. And it's really a mailbox. So when I'm away from home and I press a button on my cell phone to ask my light to turn on and off, that message actually gets sent out to the vendor's server, and it gets stored there till the device within my home requests it, okay? And then there's a little bit of latency because that message gets passed back, and hey presto, my light turns on and off. Now this is important because that's the only way they can make it work, because the limitation's the internet. But it means that they have access to all your data. If you're away from home turning your lights on and off, they're tracking this data all the time. And companies actually mine that data, okay, to look at how you use your products, how often you use your products. They can even extract data, lifetime of light bulbs, how long has it been on, do you need a replacement, okay? So when we're interacting with these devices, we need to think about this, that there's data mining, big data being gathered in the background by these devices and these systems. Okay. So how do we interact with all these different devices? So most of the products on the market, the Belkin Wemo, the Philips Hue, as we've just seen, a smartphone or a tablet, an app running on one of these devices. And really the smartphone, in my opinion, is the reason that these devices have really taken off. Without that nice graphical user interface to enable control of these devices, interaction would be much more difficult, and these devices, connected devices, wouldn't have taken off or taken off as quickly. Then there's more automated interactions. Okay, so we can have sensors that will trigger these devices for us. Okay, the occupancy sensor is a fairly obvious one, but there's daylight harvesting technology being introduced now, where sensors in your home monitor the amount of light coming in through the windows and can dim the lights down or raise them up again to ensure you've got a kind of constant amount of lighting in your house. Okay, so that's kind of semi-automated interactions. Mustn't forget, with a lot of the devices, they're still connected to power, so we've got wall switch. You've got to counter the fact that the user still wants to use the traditional wall switch and turn the device off, shut it off, meaning that we can't interact with it then from the smartphone. Okay. The kind of final one of the products that are on the market right at the moment is to use Bluetooth or some other technology already in a cell phone. Okay, and then the device that's talking to can detect when you're approaching. So there's a door lock on the market right at the moment that will open automatically if you're carrying your cell phone, because your cell phone's constantly sending out messages, and the door lock hears you approaching, hears your phone approaching, and can unlock your door automatically. So more fully automated interaction. Then you can have even more automated interactions. Okay, there's a company out there called If This Then That, IFTTT, I think it is, that's taking a lot of the products that are on the market right at the moment and creating them into channels that you can connect together however you want. So there's some really nice things you can do when you get this functionality. So for example, if you have a Philips Hue multicolor light bulb, okay, you can configure that to change color when your favorite team scores a goal by connecting the two channels up. Okay, you can monitor the score using one channel, lights, another channel, connect the two together. Another interesting application, a little bit more futuristic, but is game consoles. So we're working with a lot of the major game manufacturers. We have these connected lights and other connected devices in the home, and you can actually change the environment as you're playing the game. So for example, you're playing an adventure game, you walk into a cave, the lights can dim down, you get shot, the lights can flash red. Okay, so once we've got these devices connected, there's no end of things that we can do with them. A new technology. So before we were talking about automated interactions, we were talking about interactions with cell phones. A new technology that's supplied by NFC, supplied by NXP, and a number of other vendors is NFC, near field communication technology. Okay, built into a lot of cell phones right at the moment, often used for payment. And what it does, it's very short-range communication, okay? So that means basically the idea is you tap your cell phone on a device in order to interact with it. It's typically used to join devices to networks at the moment. So in my home, I buy a new light bulb, for example. I want to join it to my network. The problem is the light bulb doesn't have a graphical user interface. It's very difficult to tell it what the password is to my home network. With NFC, you can punch that information into your cell phone, assuming it's NFC enabled, tap that to the light bulb, assuming that's NFC enabled, and that information will be transferred across. So a very easy way to join these devices into your network. But it doesn't stop there. You can then personalize things. So I could enter a room and I could tap my cell phone onto the lighting system, and it could take all the lights down to the room into a kind of pre-configured environment that I like, and the next person comes in can do the same thing. Okay, so that's something that we're going to see in the future. Cell phones already have this technology, and we're starting to see the connected home devices, light bulbs, set-top boxes, etc., include this technology. So one to watch out for in the future. Finally, when we're talking about interactions, unwanted interactions, right? Not just you turning devices on and off as you please, but hackers, attackers. Okay, so here's one attack publicized by the LA Times. I find it a little bit theoretical, but we do know of real-life attacks that have actually happened. One case you probably read about in the press was the case of an IP camera that was hacked. It was actually being used by a family to monitor their babies. It was in their baby's room. Hacker hacks into it, can observe inside of their house. The most frightening thing really was that they could actually hack into the audio channel and they could shout at the baby in the room. So not only can they see into your house, they can actually talk into your house. So we really have to think about this with connected devices. Okay, sometimes we take it for granted. We have these all great devices and we'll go home and connect them up. We've got to be sure they're secure. There can be a lot of damage done if they're not secure. Fortunately, there's a lot of technology out there to implement the security that's required. So we have to secure the devices, obviously. They contain keys that are used to access our network, so we need specific semiconductor solutions, software solutions inside those devices. But also we need to protect the back end. We've all heard about Target recently being hacked, eBay, we've all got to change our passwords. That's all our information is stored in the servers. As we saw earlier, a lot of these products on the market use back-end servers to store data about how we use our smart devices. So we want to make sure that they're storing our data securely. Okay, so some technologies that semiconductor companies have to implement these sort of things. So we've got secure elements, okay, secure storage of keys. So we can embed these into our connected devices. And then we can be sure that a hacker, even if they steal these devices, can't get the keys out. Okay, and this could go in the back end as well. So security is an issue, yes, absolutely, but there are technologies available to prevent hackers getting in. We just need to make sure they're applied properly. Okay, so that's it. I think in summary, we've seen all these products on the market. So the connected home is really here. The Internet of Things has been here for a long time, but the connected home is really here. And I think, there's a lot of rumors about Apple going to make an announcement later in the week or next week about the connected home. So it's really growing and accelerating. And it's evolving, the way we interact with it. Traditionally at the moment with apps, et cetera, but as we've seen, NFC could be the new wave of mechanisms that we can use to interact with all these devices. And I'll say it again, security, security, security is just absolutely fundamental and critical that we get that right. So with that, if you have any questions while the next speaker gets into place, please let me know.
Questions for Ian? Here's a question. Ian?
For the tap-to-pair technology, do you use a separate IC, or is it a coil connected to an existing microcontroller? Is there active logic in there, or is this something that I could just add to my device that supports Bluetooth?
No, you're right there. It's a coil for the antenna and to transfer the power, and then it's a separate device. So usually a memory chip that in turn is connected to your existing microcontroller. So your microcontroller can go out to it, read what information has been transferred to it, and go off and do what it needs to do.
Thanks.
Okay.
More questions for Ian?
I just need to take my power supply.
One there.
You got my power supply. Great. Thank you. Thanks. Okay. Thanks. He's ready, yeah. Okay. Are you...
Hi.
Sorry.
What about interoperability between different manufacturers, specifically on the higher OSA layers?
Mm-hmm. So interoperability, there's a lot of different standards out there for the connected home. That's the real issue. Right. Philips Hue uses Zigbee. A lot of IP cameras use Wi-Fi.
I'm more specifically talking about layers 6 and 7, higher protocol layers, not just the link layers.
Oh, okay, yeah. Because that's where I was going with that. That's the real point, right? The physical layers are often different, and whilst we would like to agree on a standard, it's not going to happen. Mm-hmm. But there are a lot of efforts to agree on a standard at maybe layer 7, the application layer.
Right.
There's Qualcomm, for example, with the all-join technology. That maybe cross some of the layer boundaries.
Okay.
And there's various initiatives like that, but they're very early stage. And the big problem I see is there's no incentive for the vendors to adopt all of these standards. Right? They're quite happy having almost proprietary systems to keep people tied into their system.
Okay. Thank you.
Okay.
All right, thanks again, Ian.
Okay. Thanks.